I've mentioned scaling before, so let's talk about it. There really are two types of scaling. The first is scaling vertically. You might have heard about that term. Scaling vertically is very common. Your app runs on some service, or in the case of an app service, it runs on an app service plan. If you scale vertically, you can increase the compute and storage that you run on using a bigger server or a higher pricing tier. You can, of course, also scale back, which is the power of cloud computing. The second type of scaling is scaling horizontally. This is when your app runs, you increase its capacity by adding another instance of that same app, and another, and so on, or decreasing the amount of instances when you don't need them. Scaling vertically is also called scaling up and down. So up when you increase compute power and down when you decrease it. And scaling horizontally is called scaling out and in. Scaling easily is what makes cloud computing so powerful. You can't do that with your own server. So let's scale in Azure. Here we are again in the Azure portal. And this is the web app with our ASP.NET application deployed into it. Let's take another look at the menu. In here is an item called Scale Up App Service Plan. Let's take a look. This web app runs on an app service plan. As we talked about before, this plan represents compute, storage, and capabilities and is managed by the magic of Azure Service Fabric. Currently, this plan runs on the S1 tier. Perfectly fine. And we can scale up to one of the production tiers, which are more expensive and provide more power and capabilities. For even more power and network isolation, you can run it in the isolation mode plan, which is not available for me currently. I can also scale down to a lower tier. This includes a free tier, which works fine for development and test scenarios. Let's leave this as it is and move on. I can also scale out. This will scale the number of instances of this web app that run on this app service plan. This will increase the app's performance. Here I can change the number of instances manually. Cool. Your application needs to be ready for this. That means that it needs to be able to run without relying on local storage, like storing a file on a local disk, and also not relying on local memory, like storing temporary values in memory. And that's because the machine that your app runs on can change any minute, especially when it is deployed on a new instance. I can also use autoscale to scale the number of instances. This is very cool. And I can do this with scale conditions. A condition can be anything like a schedule or something else like a metric. Let's add a metric rule. I can use all sorts of metrics like HTTP queue length, CPU busyness, and RAM and much more to scale the number of instances. And I can make the rules for these metrics very fine-grained. This helps to optimize performance and save on costs. Cool, right?